Hey everybody, this is Todd Frazee, and this is the tutorial on developing the solid model for the counter bearing bracket. Review problem 1. For this project, you should be using the template that's provided by the school, and this lesson is going to focus on just the modeling of the part. So you should start out in the modeling tab down here at the bottom, and at home, and be in the modeling layer, so you're developing your model in it. And your workspace should be 3D modeling. Alright, so when I look at a part, I try to decide I'm going to orientate the part such that I'm working in the world coordinate system with the correct view directions, and also place the origin in a place that makes sense for the part. And I look at the function of this part, and the main function of this part is to hold a bearing, and that we want to describe in our front view the most number of details as possible. So we're going to face it so that we're looking normal to the boss feature, and that way all our other views are more supplementary, and we're defining as many dimensions as possible off that main view. It reduces the reliance on hidden lines. So that said, we're going to shift our world coordinate system to front, and then we're going to change our dynamic ECS. We're going to set that on the front view. And one thing I need to remind us to do, this drawing is in metric, so we need to make sure we set our units before we start drawing. And the quick way for me to do it is to just type in units, and we're going to change it to millimeters, and our precision can go down to 2 decimal points because that's the highest on this particular drawing. And let's hit OK. So our primary feature is going to be this circle, and we're going to place it on the origin. And a lot of engineers and drafters don't think about this, but the machinists that may set up to machine this part will develop their CAM toolpath off the model itself. So if you place the critical feature as your origin, it helps them control the tolerances based off that when it comes to machining the part. So we're going to place what I consider the primary feature. This is the bore going through the boss on 0, 0, 0 is our starting point. Zero, comma, 0, comma, 0. And that makes sure that we're starting off everything right at the origin. And we're going to change the diameter, and we have a 70 millimeter diameter for the boss. Okay, looks like I gotta zoom out. There we go. So we have our first feature. There's lots of ways to approach this. Every person will have their own way, but I'm going to start off with a couple lines that go from the center line. And the first one, I'm going to turn ortho on, will be a construction line going down. And I'm going to repeat that command and make a horizontal line. And this allows you to offset for different dimensions. Alright, so we're going to offset our first line. Now the first line I'm going to offset is, it looks like from the center of the bore to the bottom of the, what I'm going to call the angled flange, is 113 millimeters. So we're going to offset the horizontal line 113 millimeters. Now below that base flange is a keyway that's 9 millimeters farther. So we're going to go ahead and repeat that command with 9 millimeters and offset down. Okay, the flange width is a wall thickness of 19 millimeters. So again, by hitting enter, you can repeat the command. We're going to type in 19 millimeters and we'll offset straight up. Most of the horizontal lines we need to construct the profile of the part, but now we need to put in the vertical running. So if we're going to define the overall width of our part, which is 140 millimeters, that is 70 millimeters off center line. So we're going to go back to offset and we're going to put in 70 and offset our center line on both sides of our construction line. Okay, the next series of lines we're going to develop are the lines that make up the little T flange on the base flange. It gets to go in a slot, and it has a tight tolerance. It's 38.1 millimeters to 37.95 millimeters. Now I believe it's best practice to model the part at the middle of that tolerance range. It'll help the machinist out who's going to machine the part, because when they go to model it, they've got the model actual right on the center of their tolerance, and then it allows them to compensate in their software for cutter deflection and whatnot. So we're going to figure out what the average of that tolerance is, or the mean. Okay, so we're going to go 38.1 on our calculator, and we're going to subtract the bottom end of the range from it, 37.95, which gives us a tolerance range of 0.15 millimeters that feature needs to fall within. We will now divide that in half and add it to the low end of the range, which is 37.95. That gives us a keyway width that should be 38.025 to be at the medium of the at the mean of the tolerance. Now we are going to use an offset command to offset on both sides of the center line. So we need to take that figure and divide it by 2 to derive at our offset of 19.0125. So we go back to AutoCAD and we're going to offset at 19.0125 both sides of the center line. Okay, so we have most of the construction lines, base construction lines we need. We're going to do some trimming and extending, and you'll start seeing the part come to shape. So first I'm going to go to the extend command. And I'm going to extend this top edge, which represents the thickness of the base flange, and the line below it, which is the bottom half of the base flange. And we'll extend the keyway boss to its extents. Now we're going to switch over to trim. And we're going to trim off the excess lines that we don't need. Guess we could have just deleted those. Okay. Alright, so we should be looking at the end profile of the base flange. Now we need to draw the lines that are angled that make up the angled flange. Now before we do that, we're going to go take a look at our object snaps. Now what I want to accomplish is I want to draw a line from this intersection that's tangent to the circle. Now I've noticed that if we disable the center and anything that could interfere with picking up tangency, it helps when you're doing this. So let's disable center, and you need to have at least tangent selected and intersection. Okay, so now we're going to go back and we're going to use the line command. Select the intersection corner, and then we can turn ortho off. And you hover the line until you see the tangency symbol appear. Alright, you do that and click, and there we have a line that's tangent from the circle to that corner. Now let's repeat that procedure. Okay, and now we have we've defined another zone here. All right, so we're going to start this with two extrusions. One will establish the angled flange, and the other extrusion will develop the base flange, and everything else will be built from that. So we're going to go and trim this circle. Okay, so we've got everything we need there. And for the extrusion command, you need a enclosed what's called a region. So we're going to create two regions here. We're going to start with the base flange profile. And we're going to select the components of that shape we want to extrude. Once you have the whole chain done, hit enter, and it should say one region created. Okay, now we want to make another region that's this tapered flange profile, but one of the lines is common. So you can see how now when I hover over this, this whole thing will highlight. So we're going to need to make an additional line segment that connects those corners that can be part of this other region. Okay, so we're going to go to Draw, Region, and select the chains that make up our second extrusion. And hit enter. Okay, so we're going to extrude the tapered flange first. We're going to select the extrude command, and you're going to select the region. It should get all of it. If it doesn't, then you need to back up and create that region. Okay, we're going to hit enter to accept the selection, and then we're going to type in a distance. Now, flange is 19 millimeters, but I like to go to a three-dimensional view when I'm doing extrusion so I can make sure that it's going in the correct direction. So we're going to go 19 millimeters and hit enter. And what we have done now is we have created a solid body. Okay, so if I were to go to shading, you can now see that I've got a shaded solid there. Okay, I'm going to switch back to wireframe, and we're going to extrude this other flange. So we'll go to the extrude command, and we're going to select the region. We're going to accept the region, and our base flange is 70 millimeters long. So we now have produced two solid bodies that are independent to each other. We have the tapered flange, and we have the base flange. we are going to use the combine command, the solid union command, and what that does is takes those two solids and makes them into one. So we select our two solid bodies, and once we accept it, you should see a couple edges disappear, and it creates a solid. So if I were to switch back to shaded mode, this is what your model should look like. Don't forget to save. Okay, the next feature we're going to create is the boss that sticks out here. Okay, so let's make sure that your object snaps are on and you have center enabled. Okay, we're going to draw a circle, and we're going to hover over the radius that makes up the top of the base tapered flange. And you should see a highlight at the center, and we want to select that center so that it's concentric. And so we're actually drawing on the plane of the model. We then are going to select the endpoint where the line we drew tangent to the circle meets the half arc, and that'll set the diameter of our boss feature. Okay, at this point, circles that are fully enclosed do not need to be made into regions, and so we are going to extrude this circle. And once we've selected it, that's a little long. Our total height is 51 millimeters, but if you remember, we're drawing on top of the tapered flange, which is 19 millimeters thick. So we need to subtract 19 from 51, which should be 32. Okay, so that gives us a new body that's a cylinder that's on top of our flange. Now we need to put a hole through this. So what we're going to do is we're going to do a similar process where we pick up on the center of the existing boss, and that gives us the center, and we're going to switch the diameter for our units, and it is a 38.1 millimeter to 37.9 millimeter ream. Again, we want to take the average of the tolerance, and in this case it ends up being an even number. It's 38. So we're going to just put in 38 millimeters, and there we have our diameter established. Accept that by hitting enter, and now we are going to extrude another shape to use as a cutting body. And it's a little tricky. You want to select just the circle and not the entire boss. Alright, so we're going to do, we're selecting the circle, and we want to actually extrude it through the part because we're going to use this as in a subtractive method. And so we can put in, it's somewhat arbitrary, but we're going to put negative 52, which will for sure penetrate all the way through by about a millimeter there. We now are going to use the command that is covered here. It's solid subtract. So first you select the solids you want to keep, and then you hit enter, and then you select second the tool bodies they're going to be doing cutting. One advantage of doing this, you notice I didn't merge the boss with the tapered flange. When you cut multiple bodies with the same cutting tool body, it will automatically create a solid out of them. So you can save that step. So first you're selecting what you want to keep. So we want to keep these outside bodies, and we hit enter. Then it's going to ask you, what do you want to use as your cutting tool? And I'm going to rotate around to the back because we chose to make this a little bit longer. It's easier to grab onto and get the right thing. And select the cylinder. Okay, at this point, we can accept that, and it cuts through both. And in the process, it did a solid union between the two components that were cut through. And it saves a little step there. All right. Now we are on, we basically have most of the features here. The last feature we need to create and not modify with solids is the web in the middle that has a tapered top. This is the end of one of 3 videos to model this part. Please continue in part 2.